Okay, we're going to go over the test review questions that you have in your iTunes University. If you could get a calculator out, let's go ahead and work through these. These questions pretty much mirror what you're going to see on your test, so make sure that you know how to do these. So number one, a person runs a distance of 8 kilometers in half an hour. Her average speed is what? You want to make a list of your givens. Distance is 8, time is a half hour. But you want to make sure when you plug that into your calculator that you plug that in as 0.5 hours because you're dividing by a half. So my velocity is distance over time. So I get 8 over 0.5, and my answer is 16 kilometers per hour. For number two, a car is moving at a rate of 25 meters per second for 6 seconds. How far does it travel? So 25 meters per second, is that a velocity, a distance, or a time? It's a velocity, so you're going to plug in 25 meters per second. 6 seconds is your time. So to find your distance, you're going to do velocity times time. So I get 25 times 6, 150 meters. For number three, that's not moving with me, that's weird. For number three, a bike rider is changing the speed from 0 to 50 in 5 seconds. What is the acceleration? So my change in velocity is 50 meters per second. My time is 5 seconds. Acceleration is change in velocity over time. So I get 50 divided by 5. Get an answer of 10 meters per second squared. Number four, a free fall. A ball is dropped off a cliff and falls for 8 seconds. How fast is it going? Remember that gravity increases the speed of things by 10 meters per second for every second that it falls. So after 1 second it's going 10, after 2 seconds it's going 20. So how fast is it going after 8? Be going 80. And the way that you do that mathematically, velocity is just gravity times time. So I take 10 times my 8, and I get 80 meters per second. If the same ball from number 4 is falling, how far does it fall? If you remember from our hang time and reaction time labs, distance is just 5t squared. So I put 5, I square 8. 8 times 8 is 64. And 64 times 5 is 320 meters. On page 2, there are some graphs here. I want you to go ahead and draw in for A the shape of the graph that a stopped car would make. A stopped car would look something like this. And for B, the shape of a car moving at a constant speed would look like what? Like that. And on C, the shape of an accelerating car is a curve like that. So the slope of any of these graphs tells you the speed of the car, the velocity. Now for the next part here, we have velocity time graphs. So if you take a look on graph A, you want to draw what a car would look like that's moving at a constant velocity. And that's going to look like this. For graph B, a car that's braking, it's going to be a negative slope. And for graph C, a car that's accelerating, it's a positive slope like that. So any of these graphs will tell you something about the car's acceleration. So the slope of a VT graph is acceleration. On page 3, there are some definitions. You can go ahead and find those in your textbook. You want to make sure that you know the difference between distance and displacement and also between speed and velocity. So make sure you look that up for the test. And then there are some thought problems here. I'll work through number 1 with you. You and Joe are on a train, and it's moving 40 meters per second. I am in a car on the road waiting for your train to pass by. How fast are you going relative to your friend Joe inside the train? If you're both inside the train, you are going 0 meters per second relative to your friend. How fast are you going relative to my car as you go by? How fast do I see you moving, and how fast do you see me moving? That would be 40. And how fast does the train appear to be moving to me? The same, 40. If you decide to get up and move in the same direction of the train at a rate of 5 meters per second, your friend Joe sees your speed as what? 5. But I will see your speed as 45. How about if you walk back to your seat? Your friend Joe sees you coming towards you at 5, or what we could call a negative 5. Your teacher will see you moving at 35. So you can try that last thought question on your own. The boat question here, you can try on your own, see if you can work that out with your neighbor. And you want to continue to work on the note sheets that are in your iTunes U for chapters 1, 2, and 3. Now that you have your textbook codes, you can have that downloaded as well.